Hello, ngHouston. Welcome back for another episode. I'm actually really excited. This whole well, I call it night here, but it's day in Houston. It's going to be we actually have a double feature, and we've never done this before, so I think it's going to be really fun. Tonight we have Jolly on the show. I'm very excited. He's going to talk about Zone.js, and then so he's going to do an intro to Zone.js here tonight, and then right after this, he's going to jump over to Angular Air and do a deep dive of Zone.js and get more into Zone.js with Angular. I'm very interested in this because there's been a lot of talk with Zone.js with Ivy, and correct me if I'm wrong. I'm excited, so I'm getting into this a little bit before I should. But basically, a lot of people are not very interested in Zone.js. But if you have things that you're trying to do in Zone.js and you have any kind of errors that are coming out of that, it's very difficult to debug that if you don't understand Zone.js. So it's really good to have at least a little bit of an understanding of Zone.js and how it works. And also there's this whole Angular Ivy thing, which is very cool. And with Angular Ivy, then there's the to Zone.js or to not Zone.js. And it's really up to you, and you have to have a good understanding so you can make those good decisions. Anyway, but I'm getting ahead of myself because I'm just supposed to be doing introductions. I'm sorry. I'm really excited about this. Before I get into Jolly, I want to introduce my co-host, Bjorn. Bjorn, you want to say hello?
Good day again, ngHouston. Nice to see you.
Thank you so much for joining us. I love your backdrop. You're more Houston than I am now.
Do my best.
Okay, so I actually just moved and I have temporary internet, so you guys got to be patient with me. If my internet's breaking up or choppy, Bjorn is just going to jump in and carry on the show, and I'm just going to kind of hang back, and I'll just text in questions that I have. So luckily we have Bjorn. So if anything happens to my internet,
I'll be here. Don't worry about it.
He's got my back. Thank you very much, Bjorn.
Let's go.
Okay, and so without further ado, Jaws, say hello. I'm very excited to have you on the show. How are you doing today?
Yeah, thank you, Bonnie. Thank you, Bjorn. I'm so excited to be here and to join this ngHouston show. I'm a big fan of ngHouston. So today I would like to talk about Zone.js. So I think every Angular developer know about Zone.js. It is an underlying library to support Angular for all the asynchronous operations. But there are very little talks on the conference, on the online meetup. So I'm really happy I can show a more introduction or deep dive into Zone.js today. Yeah.
I think a lot of us take Zone.js for granted because it's just always been there and we didn't really have to learn about it.
I recall from the
Angular
2 times. I mean, that's a couple of years back, but I remember running into so many Zone.js issues, and I've always wondered, like, it's important to the Angular framework as a whole. I've never totally understood what its place is exactly, so I'm super curious what you have to tell us about that here.
Well, you've come to the right
place.
Yeah,
sure.
Yeah, man.
Yeah. Okay.
You want to dive right in? You want to share your screen with us?
Yeah, sure. I will share my screen. Okay. Can you see my screen?
Yeah, it looks good.
Okay. Yeah, so today we have 2 shows. First here, I would like to make a basic introduction of Zone.js by some use cases and examples. And in the next show, I will show more deep dive into Zone.js and the Zone.js, how Zone.js is used in Angular, and some features and flags may help users to develop and test synchronized operations with Zone.js more easily in Angular. So, okay, I would like to begin this introduction. So I will make introduction of myself. My name is Jolly. In fact, next week I will join this dot, and I have contributed to Zone.js about 3 years. And now I'm the co-owner of Zone.js and also the collaborator of Angular.
Cool. Congratulations.
Thank you. Okay, and so today I would like to talk about what Zone.js is and why you need Zone.js. And I will talk a little bit about how Zone.js is used in the Angular framework. So let's begin. The first is, what is Zone.js? So basically, Zone.js is a library to provide execution context that persists across asynchronous tasks. And I will talk about this sentence later. And it is a library created by Branford about, I think it is 6 years ago. And at first, it is inspired by the Dart language. And because Dart has its own zone implementation. So at first, Branford just migrate the Zone.js implementation from Dart with JavaScript. And now Zone.js is implemented, re-implemented with TypeScript and is used in Angular. So what Zone.js can do, basically it does three things. The first, Zone.js provide a zone execution context, and it also provides several lifecycle hooks across the asynchronous tasks. And finally, it provides a generic error handler for asynchronous operations. And let's talk it one by one. And the first thing I want to talk, this is the most fundamental and the most important thing about Zone.js is execution context. So the explanation of execution context, I think this sentence is from the WCC or MDN. So execution context is an abstract concept that holds information about the environment within which the current code is being executed. So I will use some code example to explain it. So here we have a very simple function, test function, and when we execute, and we can see we define a global this and to this, and when we run this test function, the JavaScript engine will provide execution context to be able to execute this test function, and to make this test function run, the JavaScript engine will need two things. The first is the scope that make test function to know what variables and what function the test function can access. This is JavaScript scope. And the second thing is to determine the magic this keyword, and to determine the value of this. So in this very basic example, when we run in the line 7, when we run test function, this will be equal to global this. And this is the very simple example to explain the execution context. And here we have a more complex example, and we have a test object, and it has a property called test function. And if we run this test function by test object dot test function here in the line 7, and we expect this will equal to test object because the context, the this will equals to the context here when we execute this test function. But if we define a new variable called new test function equal to that test object test function here, and when we run this new test function, and if you learn JavaScript, this confused me when I learned JavaScript at the very beginning. So the result will not be the test object any longer. In fact, it will become the global this. And because the context will not be the test object, it will become the global, the window or the global in Node.js. And again, if we have a new object here, and we call this, we execute this function by apply or by call here, and the context change again and become the new object here. And finally, we have another band function here, and we can bind this function to any object. So if we bound some object to function, and we execute this bound function, and the context will stay to this bound object. So there are a lot of, so this will change at the runtime, determined by the runtime, depends on how this function will be executed. So this is the JavaScript engine execution context. So it basically do two things. The first, it will determine the scope, what kind of the variables and function that the executed function can access, and it will also determine the value of this. This is magic keyword, this. So this is the JavaScript engine did. So what Zone.js did, so it basically provides another this. So this is the most important thing I want to explain. So in this code, we have a zone, and we run a function inside this zone. And just like this, because we know we can always access this inside the function. But if we run a function inside a zone, we can imagine suddenly we can access another magic keyword called Zonejs. And this Zonejs will also always equal to the zone, which is the function is executing in. And when whatever this function is synchronized or asynchronized. So in the line 4, the function is synchronized, and the Zonejs, this magic keyword, the new execution context keyword, will be equal to the zone. And if we have a SetTimeout, which is a synchronized operation, in the callback function of SetTimeout, we still have this Zonejs keyword, and this Zonejs this keyword will still equal to the zone. And so it means the callback of the SetTimeout, the Zonejs keyword will equal to the zone when the SetTimeout is scheduled. So here, the line 10, the Zonejs will equal to the execution context in the line 5 when the SetTimeout is scheduled. So
can I stop you for a minute? I want to make sure that I'm not confused. Wait, so can you go back one slide? The execution context. So no, 2 slides. Sorry. I just want to make sure that I'm clear, because this part of it is a little bit confusing. And so what you're saying is that this part of it is a little bit confusing, and that Zone.js actually kind of takes away the confusing part of it and simplifies this to make sure that you don't accidentally mess it up. Is that right? Is that kind of what you're saying?
No, basically I'm saying that the zone provides additional execution context, which is totally different with this JavaScript built-in execution this, and it is not a replacement. I think it is additional execution context. It can preserve across a synchronized task. So the this and the Zonejs, they are totally two different things. They are not replacements to each other, and Zonejs is also not an enhancement to this. It just did some another things.
So it's separated basically then to make it more clear. Yeah, to have the confusing part. This is JavaScript confusion 101. By the way, we're just showing here, like the switching context is such a pain to learn in the beginning, and Zone has that sorted to keep stuff asynchronous stuff manageable in a way. That's basically where we're going here, right? Yeah. Okay.
Yes.
I mean that clicks for me, but does it click for you, buddy? Yeah.
So all of these things, so everything that you showed us on this slide with the execution context, this still works. Nothing's going away. But then Zone.js adds kind of a simplified way to handle it so that it's more clear.
Yes, exactly.
Yeah.
Okay. Yeah.
Cool.
Okay. So as code we see here, the zone can preserve the execution context across the asynchronous operations. So these Zonejs will not change if this function is run inside this zone. It will always be the zone.
This is it.
Running in.
Exactly, and this is in addition to what you showed earlier, like where you had a function and the this there changed depending on how you ran it. But because you're calling it within zone.run, the this will stay equal to zone, and you'll always be talking about the same context here.
Exactly. Yeah.
Cool. Yeah.
So
all right. That's accidentally for me now. Yeah. Yeah. Well, it's harder to do, I guess. Yeah.
Well, you can.
Yeah, it's harder to break.
Try.
Yeah. Cool.
Yeah. So we have another Zonejs keyword to keep some kind of the context across the synchronized and asynchronous function. So not only SetTimeout. So here we can see basically every asynchronous operation, the set timeout, the promise then, the SML HTTP request, the fetch, every asynchronous context the zone can keep the zone this additional execution context when they are running in the same zone. So this is the most fundamental feature and the original motivation why zone want to do, why we have Zone.js. So this is the most important part. And we can see in the promise then, the Zonejs will also equal to the zone when the promise is scheduled. That means here. Okay, so this is the execution context. So this is a summary. So we suddenly have a new Zonejs magic variable like this, and for a synchronized operation and asynchronous operation, it will always keep the same value, which is the zone the function is running in. And of course, we didn't really add this Zonejs keyword into the JavaScript VM, the JavaScript engine. When we want to get this Zonejs variable, we need to use this syntax. The zone is a global variable, and we can access this zone at any time, and it has a static property called zone.current. And so we can use this zone.current to get this Zonejs at any function and at anywhere we want to use zone. So in the example we showed earlier, if we want to get the Zonejs, we can call zone.current. So it will always equal to the zone the function is running in. So line 2 and line 4, the value will be exactly the same.
I see. Cool.
Yeah. And also, because Zone can preserve the zone context across the asynchronous operations, so Zone actually provide a lot of hooks. Today, I will not explain all those hooks. I will explain several of the most important hooks. Those hooks will be invoked during the life cycle of all the asynchronous operations. I will use SetTimeout as an example to show when will those hooks be invoked. So this is a very, very simple SetTimeout function call. So we have SetTimeout, and we will execute this function in 1 second delay. So here is a visualized version of how SetTimeout work. So this is the stack of the JavaScript stack, and this is the web API. So the native the JavaScript engine. So it will be browser. It will be browser if we run in Chrome, and it will be the Node.js the VM the V8 engine if we run in Node.js. So first in the line 1 we will run the SetTimeout, and then we will schedule a SetTimeout. That means some function will be executed in the future. So here we just tell the web API, the browser or Node.js that we want some function to be run in the future in 1 second delay.
I see tasks in here. Tasks, is tasks a specific word in Zone.js because it's asynchronous, right? So a task, I see tasks, microtasks, and zone tasks.
Yes, in this virtualized version, we can just ignore the zone task. And the macro task here is exactly, it is not a terminology of zone. It is just a JavaScript task terminology. So yes, I did explain that. So in JavaScript, we have task and we have macro tasks such as set timeout, set interval, set immediate, all SML HTTP requests. We also have the macro task. Such as promise then or mutation observer, something like that. We want something run immediately as soon as possible. And we also have the event task, such as add event listener. So this macro task is exactly the browser, the browser provided, not a zone.
So the task is, so for asynchronous thing, a task could be queued for later, or it could be, but anything that's going to happen, is an item as a task.
Yeah, and that's because if I correct, just to make sure I get it correctly here, we need tasks in both macro and micro versions because JavaScript doesn't really do parallelism, right? Yeah, it's all synchronous under the hood, so they have to fake asynchronicity in that way, sort of.
Yes.
Yeah, exactly.
Yeah.
All right.
Okay. Yeah. So the macro task queue here is not a zone thing. It is a
Yeah, exactly. Yeah.
So here we tell the browser on Node.js we want to run some function later, and then the main stack just finished, and we have some scheduling here. The scheduling thing happened here, and after 1 second, the function will not execute immediately. The browser on Node.js will send this function to this macro task queue. So if we have several SetTimeout, they both run 1 second later, so they will be queued here. So the function callback here will not exactly run 1 second later. It may be a little longer because some function may be queued here.
Yeah, exactly.
So this is totally the JavaScript thing. Yeah. So the browser tell, okay, the 1 second delay is over, and I just send this delayed function to the macro task queue, and the macro task queue just checked, okay, there is nothing in the macro task queue, and okay, I'm the first in the macro task queue. Okay, now it's my turn to be executed. So it just sends this macro task queue, the function here, to the main stack. Then this callback SetTimeout is finally be executed. So basically, this is how JavaScript engine work for the asynchronous operation for the SetTimeout. Okay.
That was such a good. That was very. It just made it seem very simple. Thank you.
Yeah, this is good, man.
That was a really good explanation.
Keep it up, man.
Thank you. Yeah. So what Zone does? Okay. This is an additional explanation about the run order of the SetTimeout. So imagine we have the ABCD function here. If we run A and SetTimeout C, D, and B here, the run order will be here. The AB will be executed first and CD later because the order the synchronized and the delay thing. So imagine if we have some performance counter. This is the extension of the previous sample. If we really want to measure the performance of ABCD, this will never work because CD will run after the performance end.
Of course, yeah. It's always such a thing where you build something like that, and it's like, why is that not work? Oh, of course, it's not in this execution. Yeah. So interesting to see it work that way.
Yeah, this is another visualize. So the performance start and end will only calculate the AB, the runtime, the time cost of AB. The CD, in fact, will execute it later. So okay, so let's check if we run the same code SetTimeout inside the zone, and what will happen. So here, we don't need to care about the details of the syntax here. We just know that we have a zone and the zone named hook, and we define several callback here on schedule task, on invoke task, on has task, and we will explain those callback later. But inside this zone, we run the exact same SetTimeout inside this zone. And again, we have this visualized code diagram here.
Cool. Here we go again.
Okay, yeah, this is still the stack, the web API, the macro task queue. Instead, additionally, we have a zone task state will be displayed here. Okay, the first we will have the zone, and we fork a zone, and we have a new zone, and we run a function here, and we don't need to care about much about here. But okay, here, what we call in line 14 SetTimeout. In the original version, we will directly tell the web API that something will happen later in the 1 second. But here in the line 14, it will not call the web API directly. Instead, it will call this on-schedule task.
Oh, yeah. Because there's, but just try to explain, because we do zone.run, we add something. We're scheduling a task in the newly forked zone, I should say, I guess.
Yeah.
And before anything in that zone is ran, it will run its own hook first. So that gets priority.
Yes.
Okay.
Yes, exactly. And so before we really tell the native browser or Node.js that something will happen later, we will first let this on-schedule task hook be executed. So we can do something ourselves before we really schedule this set timeout. So in the on-schedule task, we can do some internal logic, anything we want to do. We can do some logging, monitoring, anything, the stack, error stack trees. Yeah, anything we want to do. And we will show some real example use cases later. But now we just know that before this set timeout is called, it is really sent to the browser or Node.js API, and the on-schedule task will first be invoked. That means something is going to be scheduled. And then we will schedule a new task inside Zone. And after the on-schedule task is invoked, and we will finally call the native set timeout. So this part is exactly the same in the previous visualized diagram. So we will call the native set timeout API. And then, because we have a new task happened, was born in this zone. There's a new task happened in this zone. So this on-has task, a new additional hook will also be triggered. So the on-has task means there is something, at first, the zone is stable, no tasks. There is no task in the zone. So the task is 0 for macro task, macro task, and event task.
Yeah, exactly.
So no tasks at all. Now we have a new task, new macro task here. So the task, so the zone becomes unstable. So the task state will become from 0 to 1. So when the task state status from 0 to 1, all the vice versa from 1 to 0, this on-has task will be invoked.
Okay.
So at this situation, the task status from 0 to 1, so this on-has task will also be invoked. And we can see the zone task state. Internally, we have a macro task count.
Yeah.
This count will become 1. Okay.
And this feels so much like the Angular lifecycle hooks because the behavior is similar because the Angular lifecycle hooks has been using Zone.js from day one since like under the hood because that's how that was created, right?
I really like to see that stack you just had there build up, like so many familiar calls I see in there. Like, oh, I've seen that one before and never knew where it came from. Or, I mean, I had an idea, but now I understand what it's actually doing right there. That's cool.
Yes. So in the Angular side, the ng zone, the logic is exactly the same. So all the hooks, all the life cycle just happens what I explained earlier. So everything just happened inside Angular 2. Yeah. So okay, so now the set timeout call is finished, and the main stack is cleared. And so the set timeout here, and browser just wait 1 second, and after 1 second, the browser just send this function callback to the JavaScript engine microtask queue, and we have a set timeout function callback here, and this is the number 1. It is exact same process, and it is my turn to be executed. And here, there is another hooks of the zone. So in the earlier version, when the callback here is executed, the code here console log will be executed immediately. But because we run this function inside the zone, so before we run this really callback, the line 15, we will invoke the onInvoke task here first. So that means some callback, some task will be invoked.
That is running within the zone context then, yeah.
Yes. So So here we can do anything we want. We know some task is being invoked, and we can do something here. And finally, the callback of this SetTimeout is being invoked here. And again, because the macro task has been invoked, it has been consumed. So the macro task has been finished. So the macro task count will become from 1 to 0. So this onHash task will be triggered again. So we can see the onHash task will be triggered again, and this macro task count will become from 1 to 0.
Internal state is updated by the hash task, like even if you don't put any internal logic or any personal logic to hook into there, the onHash task is basically the one that is updating the zone state or not.
Yes.
Okay.
Yes. So internally, the onHash. So basically, all this on whatever task, they are all optional. So Zone has its own logic to handle all those tasks, to keep the zone task state correctly. So basically, if you want to implement something additionally, you can implement on schedule task, on invoke task, on
Oh yeah, all right, like that. Yeah. So they're optionally, but the zone internally will run them anyway because it needs to run its own logic as well. Oh, okay, yeah.
Yeah, exactly. Yeah, exactly.
That is very familiar to what Angular does. Yeah.
Yes. Okay, so now because all the task count becomes 0, so zone basically is stable again. Okay, this is all the internally what happened if we run a SetTimeout inside the zone. So we have on schedule task, on invoke task, on hash task. Of course, we have a lot of another hooks such as on console task, on invoke, a lot of other hooks, but those 3 are mostly most frequently used. And if we understand those 3, and it is very easily to understand the other hooks inside the zone.
Cool.
Okay. Okay. I don't know how. Okay. Okay. So let's back to the original example. If we want to measure some performance for the A, B, C, D, and C, D is SetTimeout, and if we really want to measure exactly the time caused by the A, B, C, D, we can write some code like this. So here we still write the performance start and before the A and B, and we can also run inside the zone, which provide an on-invoke task. And in these hooks, we can add the performance start and end before this callback. So what it does, just imagine the earlier visualized version. So performance start will measure the performance of A and B. And when the C and SetTimeout C is invoked, it actually will run these 3 lines, 3, 4, 5. So it will run performance start here and run this callback. This callback will be C when the callback of C is invoked, and will be D when the D of the SetTimeout of the D is invoked. So both C and D, the performance will be measured in the on-invoke task. So we can measure the asynchronized performance by defining an on-invoke task hook here. So by in this way, we can show an example later, the real example later. So another virtualized version will look like this. Oh,
that's nice. Yeah, they're all in Zone A. Yeah. So yeah.
Yeah, because they are all in Zone A, so performance start and end will also be invoked, even they are in the asynchronous operations. And we also have E, which is okay. We have another E here. It is outside of zone, so nothing will happen because it is not in the zone. Yeah.
What's interesting about this, because maybe it's my misunderstanding, but I was expecting, if you go back one more, just about the code, because they were running in a zone, that even though there's a SetTimeout in there, I thought they were sort of like monkey patch that would run within the same execution context, and therefore performance end will not be called until C and D have been evaluated. But what I saw in the picture after is that still the same rules apply. Like performance end is called after A and B, and then C and D get their own one because they now have their own hook that are plugged into it, basically. So you cannot measure in the same way as you would expect, maybe, the performance of all four of the tasks in this way, or is there a way even?
Because in this code, that's why we have two sets of the hooks. One is called onInvoke task. Another one is called onInvoke. So in this example, only the C and D are task. They are marked.
Oh, right. Of course. Yeah. So if you would put performance end in a set timeout, it would become a task as well, and then it would run after all of it has been. Oh, I see. All right, I completely understand.
Here is a synchronized, so they are not tasks. So if we add an additional hook here onInvoke, and we write the same code, we don't need line 9.
Yeah, exactly. They'll all get their own performance test because of this. That's so cool. I understand now. Yeah, it clicked right there.
Okay. So basically, this explains how the hook things happen inside the zone. And finally, there is another feature which is also very important. It's the error handling. And we all know to handle the error happens inside a synchronized operation is very hard. Especially you want to some error be handled gracefully, and because if you do nothing, the error will just throw to the top, and until you add something like a window on error or some global error handling to catch that. So, but in Zone, you have a very good way to handle all the errors happen inside synchronized operations in one place. So there is another hook called onHandle error. And if you run the asynchronous operation inside this zone, and if any kind of error happens inside a synchronous operation, they will be catched here, the onHandle error. So you can do anything, the log, some tracing, and anything inside of this. But there is one thing need to be noticed. We not call zone.run. We call zone.run guarded. Because if we run zone.run, this onHandle error will not be triggered. So the error will still be thrown to the top. But if we want to catch, we want to onHandle error work, we need to run guarded. Call another API here. Okay, so how Zone implement all those features? So basically, it used one trick called the monkey patch. So this is how monkey patch work. Imagine we have a object API, and we have a add function here, and we call API add. It will work, and suddenly we want some additional feature, and we don't want, or sometimes we can't change the original code of the add here. So we can use some trick called the monkey patch. So we save original add function delegate here, and we redefine the API add function. And in this example, we just add a console log, and we call the original add, and we applied this context and all the arguments. So here, if we call API add 1, 2 again, it will of course return 3, but also log the API add is called. So this monkey patch trick, we can add some additional logic or your own logic, and without changing the original code. And okay, so basically, I explained how Zone.js, what Zone.js is, and what kind of the API or the functionality Zone.js provide. So additionally, so this list just show us when we should use Zone.js. So basically, Zone.js can be used for asynchronous tasks, debug, performance mirroring, and some framework auto-rendering, user action tracing, and the resource release. So I will show some example here. The first one is the long stack trees. So the code here is very simple. Imagine we have HTML and we have several buttons. The first button, when you click it, it will bind a function to the second button. And if we click the second button, it will throw an error. So this code is very, very simple here. And let's see the code here. And if we're not using Zone at all, let's see what the stack trees will look like. Okay. Okay.
Have another one here.
Here,
There's a button on the right as well.
Yes. Okay, and I will bind the error and will click this. Oh.
Yeah, I have a button on the right with unbind all the stack trace.
Okay. Yeah. Okay. So if we not use, we will not run this all those functions inside Zone. Show this code here. We just run this main function here. So we can see we just ignore all this Zone stuffs. So we can see only one meaningful stack tree here. Large.
Yes, this is good. This is good.
Yeah. Okay. So we can see only one line of the meaningful stack trees here, which is the zero error here. Which is okay, but we don't know the story. We don't know who caused this error. We only know, okay, this function is zero error, but we don't know who added the function listener for the button 2. We can't see the whole story. Okay, but if we run this in a long stack trace zone, again, we do the same thing. We can see a whole full story of the stack traces. The first, we can see it run in the, oh, not here, sorry. It's run here. Okay, we can see the error, the original cause of error is because the main, and because the button 1 at an event listener for the click, for the click event. And then we can see here, and the event and the banned second button, the banned error here, because this button was clicked, and the button 2 add his own event listener. And finally, we can see here the error was 0. So even the use all those things happen in the 2 user operations. They totally happened in the 2 button click. With the long stack trees zone, we can still trace the original cause of this error. So this is very useful for the debug.
That's a really cool example as well.
Yeah. So in fact, this long stack trees is a built-in zone spec, Zone.js provided, and it is available inside Angular 2. So in Angular test, if you run any, I think the karma test, this long stack trees zone is by default enabled there. So this
it's like the movie Red Slippers. It was there all the time, you guys.
Yeah, I now you say that it's in the Angular Karma setup for unit testing by default. It suddenly, like I recall seeing these type of traces in my, not like in my Chrome log, but in my my terminal, you know, in my console, and it makes so much more sense to see what's going on if you're aware how this works and what it's trying to do for you. This is so cool.
Yeah. Okay. And another example is about the tracing. And here, we don't need to care about the logic here. We just have a button, and inside the button handler, we random generate a lot of SetTimeout, a lot of random number of the nested SetTimeout. So that means inside the SetTimeout, we have additional SetTimeout and additional SetTimeout. We have a lot of SetTimeout. So we want to monitor how many SetTimeout was scheduled and how many SetTimeout was invoked, has finished. So it's just a counter of SetTimeout. So this is the second example, counting here. Okay. So we just see the log here, and we click start, it will randomly generate a lot of SetTimeout. So we can see the count, it changed here, and finally all SetTimeout was invoked and number becomes 0. So it is also very useful for counting some asynchronous operations. So this is just a counter, but we can also do something like all the environment, all my operation is stable or not stable, something like that. And the performance profiling is the code we showed earlier. So let's see the example profiling. Okay, the code is very simple. Let's just hit here, the profiling here. The code is very, we don't need to see the code. The code is very not relevant. So we just, when we click this start profiling, it also generates a lot of asynchronous operations, heavy work. We just simulate a lot of heavy work. And it is a sort, and we can calculate the performance marrying of all those heavy operations. We can see a more easy example in the later. Okay. Not here. Okay. Oh, okay. And we can also do something like resource auto-releasing. And by the way, Zone.js is not only work in browser environment, it can also work in any kind of JavaScript environment, such as Node.js, Electron. So any JavaScript environment can use Zone.js. So this time I want to demo a Node.js sample. So for example, to this code. So again, we don't need to care about the logic here. We just need to see what we want to do. First, we open a file, and then we want to do a lot of. We open a file, and we got a file descriptor. And imagine this file descriptor is a resource, such kind of database connection or something very expensive resource, and we want to do something based on this file descriptor. For example, in the example, we want to read file and we want to do something else with this file. Because all those operations is asynchronous. So if we want to do something like close this file descriptor, but because we use this file descriptor in several asynchronous operations, we really don't know when to close this file descriptor. So, for example, we do 2 asynchronous operations based on this file descriptor. We may need to write some code like this. We need to define task A is done, task B is done, and in all of those asynchronous callback, we will try to close this file descriptor if all those tasks are done. So such kind of code is very bad and not extensible. For example, if we want to add another asynchronous operation based on this file descriptor, we will add an additional flag and change all the original code here. So it is not a good code here. So if we use Zone, it will be much more clear. We can just use this on-has task and to try to close. If everything is stable, we just close this file descriptor. And in the user code, we don't need to care about this close. We don't need any flag any longer. We just do what the application needs to do. So this is another example that we can automatically release some resource when all the things is done. And another example is the user action tracking. So for example, in a web page, we always want to track what the user clicked. And if some error happened, we also want to know, just like the example I showed earlier, the long stack trees to show the original story, why the error happened. And we also want to do some performance marrying. So this basically wrap up a total example of all the earlier example I showed. So the example is, where is it? Okay, here. So here we have several buttons, the view order and place order and error. So view order, we can see the code here, use action. So when the view order button is clicked, we just send several HTTP requests. And order, we send additional request, another request. And error, we just asynchronous throw some error. So we want to know when the view button clicked, what happened inside, and when the order button clicked, what happened inside, and each operation, how many times they cost. So we just click this one. We can see the log here. So we can see the user action tracing here.
Mm-hmm.
Yeah. We can see button is clicked and HTTP request is sent, and HTTP request getting response, and how many times they cost.
Yeah, the costs.
So we don't need to write such kind of code. So this is the user code. We didn't add any code about those tracing, those performance marrying, such user action grouping. We didn't add any such kind of code inside the application, user application code. So user don't need to care about anything about that. We only do those things inside a zone. So here is the application code. All the heavy work is done by a central place, the zone. And if we click this place order, we can see two button click is grouped. The user action is grouped. We can see what is happened inside one button click and how many times they cost. So this is also very easily to do such kind of user action tracking. And if we click arrow, of course, we can see a long stack tree, just like the sample I showed earlier. So this is also a perfect library for the user tracking. And the UI auto rendering, of course, this is what the ngZone does. So for example, here, there is the, not this one.
I love this because if you're some of this functionality that you're showing us, like I've seen this before, I've done this before, but it's like if you don't know it's there, then you're going to write a bunch of extra code that you don't actually need.
That's so true. Like I'm so inspired right now to take a dive in like just write something that works like this, or that I want to get some more additional tracing from, and do it with Zone, because why not, right? So
We're getting very excited about this, Josh.
Yeah.
Awesome. Thank you. And this one is the UI auto rendering, which is something like what Angular ngZone does. So here in the auto rendering, we just have some button click, and with this one we just request something from HTTP, and here we just have SetTimeout, and here we just have some number be increased. So this is just what we did in the application code, and here we want to show this data on this div. But we don't want to manually update the DOM. We don't want to automatically manually update the UI. So what we did, we can use Zone. So here in the demo, so after HTTP request, we can see HTTP get data and timeout and add the number just increased. And we didn't add anything about update UI in the application code because Zone handle everything of that. So basically, not exactly the same, but basically this is what ngZone worked. So ngZone handle all of those things, and the ngZone know when to trigger transaction, and so to update the UI.
Super cool. Yeah.
Okay. Yeah. And of course, Zone.js is not only for the runtime. It also very important for the testing, for the asynchronous test, or especially when we write asynchronous testing. So here is the example. If we don't use Zone.js, this is just an example. We have some asynchronous thing. We need to use this done. And inside the callback, we need to call the done manually. So we need to care about when the asynchronous operation is really finished, and we need to call this done manually. And with async, this is another zone spec provided by Zone.js. And this async inside it is also a functionality provided in the Angular core testing. And with async, just like the demo I showed, the async zone spec know when all tasks finished. So when all tasks finished, it will automatically call this done for you. So it's just something like a syntax sugar or something like that. So basically, they are equal, but it will automatically call this done for you. So you don't need to worry about when should I call done, when all those asynchronous tasks finish. I just write my test code here.
On behalf of the QA engineers that I know, very much thank you. This is such a helpful tool. I know they use it. Yeah. I didn't know Zone provided it. This is so cool. I'll tell them tomorrow that I talked to one of the guys that mailed it. So cool, dude.
Yeah. Yeah, okay. And another example is about the fake sync. This is also provided by Zone. So imagine we have a very, very long async operation. Here is 10 seconds. Of course, we can run this test, but if it will cost a lot of time, you have to wait there. Yeah, this is really, and cause all the tests unstable, flaky. And basically, we want to test something here. We don't really want to wait for this 10 seconds. So we can use this fake sync. It is another Zone spec. So what this fake sync does, it make everything that the set timeout, not everything, everything time
dependent,
operation related to the time, and make them fake. So it implement a fake scheduler to handle those asynchronous operations. So this set timeout 10 seconds will not really call the browser API. It just tell I want to execute some code in 10 seconds later, and if you call tick, it will advance a virtual timer
clock. Yeah, so the internal.
Internal clock. So this callback will be invoked. So all those asynchronous tasks become synchronized. So it will make the task much faster and much stable. So this is also a built-in function provided by Zone.js and Angular core testing.
I love that one. I knew about that, but I didn't know it came from Zone.js. But I love.
Yeah, same. I've seen it. I've seen it used multiple times, but I never knew that Zone provided that.
Because it's just faster.
Yeah.
Exactly. Yeah. Okay, so this is basically it is the basic introduction of Zone.js, and all those features are used in Angular 2, and we know we have an ngZone to tell Angular when to trigger transaction, and we have all those asynchronous, fake sync test, and another sync test, Zone spec to help user to write more efficient synchronized test code, and we have the global error handler, which is also used on handle error hooks provided by Zone. And we also have the task tracking long stack trace zone. We can enable them in Angular.
which you
they
showed.
are automatically enabled in the test environment. So they are also provided by Zone. So a lot of things, basically everything of Zone.js functionality is used in Angular. So I will not talk about the feature of the Angular here. So we can talk about in the later Angular Air show. But I will just show one thing that ngZone provide. So there is a function because those two methods basically the developer may use in their application. The first one is ngZone.run. This makes sure the function here run inside Angular Zone, so the chain detection will be triggered. And sometimes you want something not trigger chain detection, you will call run outside Angular. So the code here will run outside Angular Zone. So basically, this is the most frequently used zone-related method. Yeah.
For people that don't know how Zone works now.
Yeah. So basically, I think most developers know those two methods. Yeah, but not the underlying Zone, how Zone.js work. Yeah. And finally, I will thank you all the Angular community, Angular team, help me to do all those Zone.js contribution, especially Mishko. I still remember 3 years ago, Zone.js is my first open source contribution, and Mishko gave a lot of his time to guide me how to do all the documentation, all the tests, and do a lot of code review to help me to really join this community and become now I become the code owner. So I really thank you, Mishko, and all the Angular community. And of course, thank you, ngHouston, to give me this chance to show how Zone.js work.
No, thank you.
That was awesome.
I always say sometimes the guys who actually write the code aren't necessarily the best teachers because they've been looking at it for so long that it seems easy and it's hard for them to explain it in a way that people can understand. But you actually explain this very well because some of this stuff is pretty complicated and you explained it and with the console logs and with the diagrams, especially together, that you really made it very easy to follow and understand. And we really appreciate you. Thank you so much.
This was excellent. What a great talk, man. Fantastic job.
So Zone.js keeps coming up around conversations around Angular Ivy. They're doing some interesting things with Angular Ivy, and that's actually, I mean, I thought that Zone.js was very interesting before that, but that was really kind of what made me want to go in and actually learn more about it, learn more about chain detection and stuff. So there's more to come. But even with Ivy, Zone.js, like there's still it's still like it's optional. You can use it or not use it. But sometimes there are reasons why you still want to use it. You might not want to use it, but you still want to know more about that. So we're going to dive more into using Zone.js specifically with Angular going forward, coming up on Angular Air, which is in about an hour. So
a little time
stop. We'll take a break. Yeah. Everybody go stretch your legs. And we'll see you back. Sure. Thank you again, Jolly. I really appreciate you coming on and teaching us. Thank you, Bjorn, for really great questions. And we'll see you guys next week.
See you next week.
Bye-bye.
Yeah.
Bye-bye.
Thank you. Bye-bye.